Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. And in today's video, we'll be looking at Microsoft Azure ML. There are many components of Azure. I'll be specifically focusing on the machine learning component. What are the objectives of this particular video? We'll be looking at how we can sign into Azure. Secondly, I'll also be demonstrating how we can upload a file in Azure. Thirdly, what are the different modules, what are the different features in Azure? Fourthly, we'll be talking about the different machine learning applications. Specifically, I'll be building a linear regression model in this stage. We'll be building, training, and scoring a linear regression model. Lastly, we'll be looking at how can we evaluate the model that we have built. But even before I show you how we can access Azure ML, what exactly do we mean by Azure ML? Azure Machine Learning, or simply Azure ML, is a cloud-based service. Secondly, this is a machine learning platform which helps us import any file. We can import a CSV file, an Excel file, a Hive-based file, SQL, or we can pull a file from any other database. Secondly, it helps in data pre-processing and transformation. Thirdly, it is very good for data visualization. Fourthly, it helps us in NLP, natural language processing, as well as computer vision technologies. Fifthly, we can embed R as well as Python codes in our workstream. Lastly, Azure ML can help us scale, distribute, as well as deploy our workloads to the cloud. So this is a high-level perspective about Azure. With this, I will now move on to Google. In Google, I'll be demonstrating how we can sign into Azure. So this is Google search. I can just type studio.azureml. The very first link, which reads Microsoft Azure Machine Learning Studio. I'll anyway be pasting this particular link in the description. Please feel free to click on the link and access Microsoft Azure Machine Learning Studio. It is a GUI-based integrated development environment for constructing and operationalizing machine learning workflow on Azure. The moment you click on this particular link, what happens is that you will get a sign-in button here, using which you can sign into Azure. If you have a Skype credential, or if you have your Outlook credentials, the same credentials can be supplied here. You have to just type the name and the password. It will work as fine. Now, since I already have signed in, all that I can do is I can just click on this button which says My Experiments. If you're doing this for the first time, you'll not be given this particular option, that is My Experiments. What Azure will do is it'll ask you for the username and password. And as I just now mentioned, you can supply your Skype credentials or your Outlook credentials or any other Microsoft Office credentials. It should work. Let me click on My Experiments. It'll take a couple of seconds to load the experiment. I don't need to see this message. Not now. Right. So this is your go-to page. As you can see here, it reads Microsoft Machine Learning Studio. You see a couple of options called as dataset, module, project, and experiment. What you can do is you can click on the blank experiment. Since we are beginning this experiment freshly, you can choose this option, blank experiment. Azure also provides a lot of templates wherein they have already built some of these modules. You can just click on any of these applications. You can click on any of these templates. They have many applications for linear regression, support vector machine. They have applications for domain-specific problems, maybe banking or telecom. You have a whole lot of applications. I will not be going into any of these things. I will simply choose the option blank experiment. What do you see here? To the left side, what you see is your workspace. And to the right side, what you see is nothing but the canvas which you will be using to construct a machine learning workflow. You can, with the help of different modules that are present in the left side, create a workbench for yourself. It says experiment created on a particular date. I want to remove this. The current experiment that I will be working on is car sales prediction. I will just say V1 because this is the first version. Okay, let's examine some of the features to the left side. What all features do we have on the left-hand side? Now, there are different options that you can access. What is called as saved dataset. You can expand this by clicking on this icon. You have what is called as my datasets as well as sample files. Azure provides a lot of sample files which you can use for machine learning activities. You can see here some of the files like census data, airport codes dataset, automobile price data. So it's very helpful in that sense. I'll not be using these files as of now. Let me just give you a high-level perspective about some of these options. You can do data format conversion. You can also click on data input and output. We normally don't use this. Data transformation is very, very useful because the raw data many times does not give us good models. This is where data transformation comes into picture. If you click on this particular module, you see a whole lot of options like filter, learning with counts, manipulation. You can split the file, so on and so forth. You also have what is called as feature selection, and something which might interest you would be the machine learning option. You have options to evaluate, initialize a model, score the model, as well as train the model. Let me choose initialize model. You have 4 different options. One is what is called as anomaly detection. Second one, if the outcome that you are interested in is a classification based outcome, let's say you want to predict fraud versus non-fraud, or let's say you want to predict churners versus non-churners, you can do a classification model. There are a lot of options here. You can see here around 15-20 different options are there. I will not be explaining this in this particular video. You can do unsupervised learning technique as well. They provide what is called as k-means clustering. And then we can do linear regression, not just regression. When you click on the regression module, you have 8 different options. Right. You can also work on OpenCV library modules, Python language modules, R language modules. You can use a lot of statistical functions, text analytics, time series, web services, so on and so forth. Now let's start from the scratch. What you see on the right-hand side is a workbench. Now this workbench has not been populated. When you see certain description here, what Azure is trying to do is it is giving you certain hints as to how we can kickstart the process of modeling. You can see here, it says to create your experiment, drag and drop data sets and modules here. As it clearly says, this is a drag and drop technology. You don't need to write one single line of code when you're working on Azure. So it is asking me to drag items here. Even before I kickstart the process of uploading a file and then creating a model, I like to show you the data set that I will be working on. So this is the file that I will be working on. It is called as car sales data set. You can see here, there are very useful variables like manufacturer of the motor vehicle, the model of the vehicle, sales variable, very, very interesting. So I will be working on this particular variable. This is my dependent variable. I've got other variables like resale value, type of the vehicle, price. Then I have engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, mileage per gallon. And then I have log sales. The original variable sales has been converted by applying log transformation. Then you have all these Z transformed variables like Z resale, Z type, Z price, so on and so forth. So this is the source data which I will be working on. What is the sample size in this data set? As you can see here, the sample size in this data set is 158. So this is the data set that I need to upload into Azure. Right now, it is in a CSV format. The question is, how do we upload this file and load this particular file in Azure. To do this, let me go back to Azure Studio. So to upload any file, what you can do is, there are a couple of options here. The easy one is what I'll be talking about in today's video. You can see a button to the left-hand side corner which says New. Let me click on the option New. It has a plus sign here. You can click on New button. It opens up a new page. Right at the top, you can see an option which is called as dataset. I want to upload a dataset. Therefore, I'll choose the option dataset here. Now it is asking me from a local file. Yes, I want to upload from a local file. I can choose this particular option. A small window appears wherein it gives me the option to specify the name of the file as well as set the path of the file. As you can see here, upload a new data set, select the data to upload. Choose file. I can click on this particular button, choose file. And you can choose a file from desktop, C drive, D drive, from any of these locations. You can choose a file. What I'll do is I'll go to statistics or samples. I can choose the file car sales, but even before I select this car sales, let me make sure that I close the source file. I'll close the source file and choose car sales. This is a file which is located in desktop, and I've created folder and subfolder, namely R samples. Let me click on the open button. As you can see here, the moment I set the path and choose the file, existing data set is car_sales.csv. This is the CSV file which I will be working on. Generic CSV file with a header. Yes, let me click on OK. As you can see here, Azure is uploading a new data set which is called as car_sales.csv. It takes a couple of moments to upload the file. Yes, once it uploads the file, it gives a message saying upload of the data set car_sales.csv has completed. Fantastic. I can just click on the option OK. Now, I've uploaded the file. I don't know where the file is. How do I locate the file? You can see this particular module, which is called as saved dataset. Please expand my datasets. This is the option, my datasets. The moment you click on my datasets, the uploaded file, namely car sales, is displayed here. This is the file that I will be working on. All that I need to do is drag this and drop it into the canvas on the right-hand side. Azure is very, very easy. You'll be using a lot of right click. Just with right clicking, you can build a solid, robust model. Now, you may ask me, what is the guarantee that all the fields have been uploaded? Remember, my source data had around 157 records, and you had various data, various details about car sales. To download the data set, what you can do is select this particular feature and say right click and simply say download. I don't want to download. All that I need to do is visualize the data set. So I'll be choosing the last but one option, which is called as data set. And here there are three options. First is download. Second one is visualize. Very, very simple. Just right click, go to data set, and then choose visualize. It takes a couple of seconds and it gives back it displays the data set. As you can see here, Azure gives me a description of the number of rows. There are 157 rows and there are 26 columns in this data set. The first column is manufacture, second is model, third one is sales, resale, so on and so forth. All the fields that you saw in the spreadsheet are displayed here. You can see all the Z transformed variables. And if I scroll to the left side, all the original variables are present. The most important variable in this analysis would be sales. So let me select the variable sales because this is the dependent variable. I am trying to predict which all features influence sales. The moment I click on sales, what do you see at the right-hand side? You see all the descriptive statistics pertaining to the variable sales. What is the average sales, which is 52 point something, median 29 point something, what is the minimum, maximum, standard deviation, unique values. It also gives me how many missing values are there. In the variable sales, there are 0 missing cases. And what is the feature type? It is a numeric feature. Please remember, when you want to use a linear regression model, the dependent variable must be a scale variable. It has to be a numeric feature. If I scroll down, you can see here, it produces a histogram for the variable sales. So this is a histogram. What is my first impression when I look at the histogram? My first impression is that the variable sales is not normally distributed. It is skewed. You can also plot sales log scale. Okay, you can choose the log scale. Now it appears, you can see a different visualization here. This is after taking the log transformation. Now it is not exactly normal, but it is a lot better than the original variable. Let me compare this with the original variable. All that I need to do is unclick. I'll get the original variable. I'll get the distribution of the original variable. If I click on log scale, it will give me the log transform distribution. If I scroll down, you can see here, by default, it runs on 10 bins. I can change it to 5 or 6 buckets. I can use a probability density. Now, is this normal? May not be exactly normal, but it is better than the original variable for sales. I'll just unclick some of these things. Now, as you can see here, how easy it is. In just one click of the mouse, you are able to get the sample size, number of columns, the number of missing cases. You don't need to install any library. You don't need to keep any. You don't need to keep any functions or functionalities in mind. It is just point and click. This is how simple Azure is, and it is one of the major tools which is unleashing the no-code revolution. Without writing one single line of code, you can build a machine learning model. So by default, we can construct a histogram. Let me go to visualization. And if you choose another variable, if you want to check the distribution of sales, let's say with mileage per gallon. As you can see here, I want to select the second variable. All that I need to do is click on the drop-down menu. And here, I will be choosing the second variable, namely mileage per gallon. Let me scroll down. You can see here mileage per gallon is in the y-axis and sales is in the x-axis. I would have liked to flip this, that is sales, I would have liked it in the y-axis and mileage in the x-axis. But never mind, you can see when you specify 2 variables, you will be given a scatter plot. When you choose only one variable, Azure produces a histogram. So with this, what I have done is I have loaded my file in Azure ML. Let me close this window. So this is the icon with which I'll be able to load the file. What is the next step? The next step is that you have 26 variables in the data set. For machine learning, I will not be using all 26 variables. I will be limiting the analysis with only 10 or 12 variables. The 12 most important variables which are relevant for the machine learning model, namely linear regression, only those variables I will be selecting. So this gives me an opportunity to access what is called as select columns. How do we access select columns? Let me remove the expand option. You can see here, there is a module which is called as data transformation. I'll have to expand data transformation. Once you expand the data transformation, you are shown 5 options: filter, learning with counts, manipulation, and then sample and split. Let me click on this. You are again shown partition and sample, and then split data. I don't need this particular option. What I need is basically select columns. I am not able to locate the option select columns. So when you can't select the column like this, what you can do is either you can type select columns here, Or let me give a shot with manipulation. Do I have the option of selecting columns here? Yes, you can see here, select columns in the data set, select columns transform. I'll choose the icon, select columns in the data set. I just need to drag and drop this particular feature here. You can see here, the properties window controls the properties of this particular feature. You can see here, there is a circle here, which you can use to connect to the input port. So information will propagate from the first feature to the second feature. You can see here, there is a warning message here. It says values required. I have just attached select columns feature, but I have not selected the columns. And therefore, it is unhappy with my choice. To the right side, you can decide which all columns would you select. When you look at the heading here, it says select columns, launch column selector. Just click on this particular button. A new dialog box will help you select the variables. Manufacturer and model, these are string variables. I don't need this. I will choose sales, resale value, type, price, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, and mileage. Let me click on this particular option. Click on OK. Now you can see the red color warning message that you were getting earlier has disappeared. Now we are good to go. Once you click on, once you select any particular feature, what you can do is right click on this and you can simply say run selected. This is the option that you need to click. Either you can choose this particular option or you can select a particular node and simply click on the option run selected. Azure will run this particular feature and it will select only those columns which I have filtered in the data set. I have from 26 variables, I should be having just 10 or 11 variables now. So I have filtered my data set. In the first step, I have loaded the data set. In the second step, what I have done is I have filtered the data set and limited to only the most important variables. What is the third step? The third step in this exercise is to split the file. Why do we split the file? Usually when we build a machine learning model, we split the data set as training and testing. 70% of the cases from the base data will be going to training and 30% of the cases will be going to test. Training data set, as the name itself suggests, is used to train the model. Test data set is utilized to check the performance of the model. So the third step in this exercise is to split the data set. What you can do is, since there are so many features, it becomes a bit difficult to remember in which module a particular option will appear in. So you can simply type here split. The moment you click on split here, you can see here Azure directly goes to sample and split module. Within this, it is able to display split data. So you can just drag and drop this particular node in the canvas to the right side. As you can see here, it has one input port and it has two output ports. Let me establish a connection with the split file. What do I need to do? I need to look at the properties window at the right side. The default is that you can see here, it says split the rows. Okay, I'm happy with that. Fraction of rows in the first output data set. I need 70. Usually I choose 70, but for this purpose, I'll choose 80%. You have different options to choose from. You can stratify as well. I will not be going into those options now. Let me select this particular option and simply say run. What this should give me is it should give me two different data sets. First is training and the second one is test data set. Let me hover the mouse in the first circle, you can see here results dataset 1. This has 80% of the training data set. If I hover my mouse to the second circle, this is going to give me the second data set, which is the 20% test data set. So in the first option, I have loaded. In the second option, I have selected only few columns, like you can read here: sales, resale, price, engine size, so on and so forth. Here, I've made sure that I have split the data set. If you want here, you can download this data set, but I will just skip that particular option as of now. What next? The next option is that we need to train the model. How do we train the model? So let me just go here and type train model. When you click on the option train, what Azure does is it displays a lot of options. But under the train option here, you can see there is a feature which is called as train model. This is very, very important to us. It says train a previously created classification or regression module. I will ignore this. I'll ignore the description, but choose the feature here. This is the option that I need to click on. I will be training the model. How do we train the model? There are two input nodes. If you observe clearly here, earlier you had only one input node. Here, the training model requires two inputs. This is the first input, and this is the second input. The second input is quite easy to figure out because it is expecting a data set. Where is the data set going to come from? That is the question. So the data set that I will be using will be the output from the split file. So by establishing a connection between the split data and training data, what I'm doing is I'm feeding the training data set into the train model. Remember, the test data set is within this place. It is in this circle. I'm not going to utilize it as of now. It is not sufficient to feed the data set. You need a learner as well. A learner is simply a machine learning module. What is the model that I will be using? I will be using a model which is called as linear regression model. You may ask me, why am I using linear regression model? Because the dependent variable here is sales, which is a scale variable. To predict a scale variable, you have to use a linear regression model. And this is the mother of all models. In fact, if you can master linear regression and logistic regression, a lot of machine learning models will be a lot easier for you. So where do I access the linear regression option? You can see here, I'm already in the machine learning option. You can see here, this is the machine learning. This is the machine learning option. So there are quite a few options: score, train. Okay, I need to access the linear regression model. Okay, let me type the linear regression model here. All that I need to do is just type in the search button, and you can see here under the linear regression model, you have initialized model, and then within the regression option, you have two different options. One is what is called as a Bayesian linear regression model, and the second one is your vanilla linear regression model. So all that I need to do is drag this and drop it. Let me drop it here. It's a lot better. You can see here, I have to train my model using the training data set. So in the first input node, I will establish a connection. Wow. You can see here in the first step, I have loaded the data set. I have selected a few columns. Then I have decided to split the data set into training and testing. When you see one here, this is nothing but training data set. When you look at the second circle here, this is the test data set. And then I have used the train model. I need to supply a learner or a machine learning model. And I also need to feed the training data set here. It is still not happy. It is crying here because it says that it does not know what to train it on. In other words, I have not specified the dependent column here. Let me click on this particular option and you can choose here. It says label column, okay, launch column selector. Fine. The column that I wanted to train on would be sales. I will be choosing the option sales and then I will click OK. So the train model option is very, very important because we are feeding the training data set at this stage. We are using the learner. Unlike many other options, it's very easy to be misled here because there are two inputs. The first port, you supply a machine learning model, and in the second port, you'll be feeding the training data set. You'll still get an error message simply because you'll have to specify the dependent variable. So these are the three most important things that you need to keep in mind. From the output of the split data, what you can do is you can feed the training data set into the train model. From the output of linear regression, you can establish a connection to the input port to train the training data set using the linear regression model. Now, what I'll do is I can click on the option run. So all these models, or all these options or features will be run. If you see a tick mark, it means that Azure has successfully executed the job. If not, there will be no tick mark. You will get an error message. So fantastic. At this stage, we have trained or we have fitted the model. If you want to see the predictor importance, which is the most important predictor, which is the least important predictor, what you can do is you have to click on what is called as feature selection. And therefore, you can choose what is called as filter-based feature selection. This option is present under the module feature selection. So you can see here, the moment I bring the mouse on that particular option, filter-based feature selection, Azure provides a description. It says, identifies the features in a data set with the greatest predictive power. I want to be able to identify the three best predictors which drives the sales of the vehicles. So let me drag and drop this node in the canvas on the right side. Once I drag this and drop it, what is the next thing? Once I drag this and drop it, I can establish a connection from the split data to filter-based selection. Filter-based feature selection. Now here you have a few options. You can click on the drop-down menu. You can choose based on Pearson's correlation, mutual information, Kendall correlation, Spearman correlation, chi-square, Fisher score, count-based. If you have categorical variable, then perhaps you could use chi-squared. If you have a small sample, you could use Spearman correlation. Here, I'll choose the default option of Pearson's correlation. Select columns, it says, launch the selector tool to make a selection. Launch the column selector. I'll be clicking on this particular button here. I will select all the variables which I would need to check which are the most important features. In fact, I can just choose sales because this is the dependent variable. It is asking me for the dependent variable. So I can just choose sales and click on OK. Let me right click and then say run selected. So this should give me the feature importance. It takes a couple of moments to run this particular node. It has successfully executed this particular node. Let me right click and then say features. Let me just visualize. You can see here, these are the variables which I had supplied. This is the first variable. Wheelbase is coming out to be the most important variable. So it has 38% importance. Second most important variable is price. So wheelbase, price, resale value are the three most important variables. The fourth important variable is type and length. And when I scroll to the right side, you also have other variables like curb weight, mileage per gallon, and engine size. Its importance is barely 1%. So the last three variables either have 1% or less than 1% importance. Look at some of the initial level variables. Wheelbase has 38% predictive power. Price has 32. You have resale value, which has around 30% importance. So most of these variables like wheelbase, price, and resale are the most important variables. Now, if you want, you can just keep this, or you can just delete this, because this is not the main goal of the presentation today. So after training the model, what is the next thing? We need to score the model on the test data. To score the model, what you can do is either you can identify the score model option by scrolling down, which is slightly tedious, and therefore I'll choose the option score. I'll just simply type score in the search. You can see the option score model. All that I need to do is drag and drop it here. In the canvas, you can see the score model. Now it is asking me to feed it the test data. You can see here, there are two input nodes again here. Now the first input node will be from the train model. And in the second input node, what I will be doing is I will be establishing a connection and feeding the test data. So if you recall here, the second data set was stored here. I had not yet used here. I will be establishing a connection to the scored model, because the 20% of the test data will be used to apply the model and get the score. Score model. This will help me score. I can quickly choose the option run selected. If all is well, we should be able to get the predictions on the scored model. You get a tick mark, which indicates that there is nothing wrong. Remember, there are two inputs. One is basically you're applying the trained model on the test data set. You need the test data set. So under the split file, the second data set will be fed into the what is the last of the options. I know that you have been very, very patient. So this is the last option. Once I have split the data set, trained my model, scored it, the last of the options here is to simply evaluate the performance of the model. So how do I evaluate the performance of the model? Now, to evaluate the performance of the model, you have an option which is called as evaluate model. Just drag and drop this particular feature to the canvas on the right side. Once you do this, you can establish a connection with evaluate model. Right click and simply say run selector. So this will give me the overall performance of my model. It has run successfully. I'd like to examine the contents of this particular node. So let me just say visualize. Wow. You can see here, it displays 5 different metrics which tell me the quality of the model. The first one is what is called as mean absolute error. Lower the value, better the model. Root mean square error. Root mean square error is very, very important. The third metric here is relative absolute error. The fourth important metric is relative squared error. The last metric is coefficient of determination, or simply R square. I'll be interpreting the last metric, namely coefficient of determination. Coefficient of determination, or R square, it lies between 0 and 1. It tells you the model goodness of fit. If the model fits the data well, your coefficient of determination should be greater than 0.7. If the coefficient of determination value is greater than 0.7, it means that the model fits the data well. On the other hand, if the coefficient of determination value is less than 0.7, it means that the model does not fit the data well. What is the coefficient of determination value that I'm getting here? It is 0.01, which means that only 1% of the variation in sales is explained by the set of independent variables that I have supplied. I repeat, only 1% of the variation, which is not at all good. The remaining 99% of the variation is not explained by the model. Ideally speaking, I want the model to explain more than 70% of the variation. You also have some people look at the coefficient of determination, others look at what is called as Ramsey or root mean square error. What is the ideal cutoff? Based on the rule of thumb, it can be said that RMSE must lie between 0.2 and 0.5. If the value of RMSE is between 0.2 and 0.5, it indicates that the model can relatively predict the data accurately. So this is what it means. You also have a graph for error terms. If the error terms, you can see here in the x-axis, you have the error term. This is not normally distributed. One of the assumptions behind using linear regression is that the error term should follow normality with mean 0 and variance and a constant variance, right? Error term should have a mean 0 and it should have a constant variance. It looks like when I look at the coefficient of determination, I am not getting a good model. It is barely 1%. Question is, can I improve the model? I can improve the model. Linear regression works best when the dependent variable is normally distributed. So if the dependent variable is normal, then linear regression gives appropriate results, else you may not get appropriate results. So let me just tune the model slightly. How do I tune the model? Select columns in the data set, right? This is the second node. Let me choose the option launch column selector. You have the variable sales. I will remove the variable sales, and instead of the variable sales, I will choose the variable log sales. Why? Because you saw in the visualization that log sales fits the data well, but sales, the original variable of sales, is not normally distributed. However, log transformed sales fits the data better. Since log transformed sales fits the data well, I will be modeling the variables on log sales, not sales. One other change that I need to do is go to train model. You can see here earlier I had specified sales. Let me go to launch column selector. I will remove this particular option and look for log sales. This is what I want. Here I'm not looking at the feature importance, so you can just simply delete this. The other connections look good. So let me just rerun the entire model. It would take some time because, as you can see here, it has to run from the beginning. Why should it run from the beginning? In the second step itself, I have changed the dependent variable from sales to log sales. Remember this point, that it is best if the dependent variable follows normal distribution when you're fitting a linear regression model. Fantastic. We have been able to run the model successfully. Earlier, I got a coefficient of determination of 1%. Let me examine what is the R square now. Not bad. Please take a look at the R square value. It is 0.270. In fact, there is a negative value here. Otherwise, it is 0.270. You might want to clean the data. You might want to clean the data and then rebuild the model. R square, which is greater than 0.7, always is a good indication. Below 0.7, we don't take the model that seriously. Now, You can look at some of the other values as well, like root mean square error, a relative absolute error, a relative squared error, mean absolute error. All of these metrics have come closer to zero, which is a good sign. So this is how we can build a linear regression model in Azure. Going forward, I'll be creating a separate playlist for Azure, wherein I'll be making other models as well, like logistic regression, decision tree, random forest, and we will look at how to create an API and deploy these models in a real-time scenario. I thank you very much for watching this video. I request you to subscribe to my channel and share these videos with your relatives and colleagues. Thank you very much. Have a great day.